Hello guys.
Hi,
I'm Martha,
I'm Azmil.
and I'm Razi.
and we're from Group 6.
We're going to explain the usage of thermodynamics.
In real life.
Thermodynamics can be defined as the science of energy. Although everybody has a feeling of what energy is, it is difficult to give a precise definition for it. Energy can be viewed as the ability to cause changes. The name thermodynamics stems from Greek words. Therm is heat and dynamics is power, which is most descriptive of the early efforts to convert heat into power. Today, the same name is broadly interpreted to include all aspects of energy and energy transformations, including power generations, refrigerations, and relationships among the properties of matter. Thermodynamics is a study of the effects of work, heat, and energy on a system. A system is a region under study which is separated by a boundary, which are real or imaginary boundary. Work is the energy transfer associated with a force acting through a distance, while heat is the form of energy that is transferred between the two systems or a system and its surroundings by virtue of temperature difference. Work, heat, and matter can go either way across a boundary. In this video, we are going to help Mr. Ali to solve his problem by using the first law of thermodynamics. The first law of thermodynamics is a version of the law of the conservation of energy adapted for thermodynamic systems. The law of conservation of energy states that the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can be neither created nor destroyed.
It was on one fine sunny day where Auntie Ali decided to have a ride on his bicycle. In order to not feel tired after he rides his bicycle, he must have sufficient energy inside his body. How Auntie Ali is going to achieve that? Fear not, by using the first law of thermodynamics, the energy needed can be calculated. The total of heat loss due to surrounding is 82 kilojoules, while the total of work done on the bicycle is 500 kilojoules. The question is, how many kilojoules of food needed to be consumed in order to have enough energy to ride the bicycle? Here's an example of a simple diet that Inche Ali can take in order to have enough energy to ride a bicycle. Note to be taken that these are just an assumption of energy that is used when riding a bicycle. In order to do work on the bicycle, food energy must be higher than work and heat loss to the surrounding itself. so that Insha'Allah will have much more energy to keep on his day. To calculate the amount of energy that Insha'Allah will have after he consumes his food, let us use the first law of thermodynamics equation, where energy going in minus energy going out equals to the energy inside a system. As the first law of thermodynamics clearly states that energy cannot be changed nor destroyed. With enough amount of energy inside his body, Insha'Allah can continue to ride his bicycle happily.
In simple words, the first law of the thermodynamics states that whenever heat energy is added to a system from outside, some of the energy stay in the system and the rest get consumed in the form of work. Energy that stays in the system increases the internal energy of the system. This internal energy of the system can be manifested in various different forms: kinetic energy of molecule, potential energy of molecule, and heat energy. First law of thermodynamics in Dutch conventionally states as the change in internal energy of a closed system is equal to the energy added to it in the form of heat Q plus the work W done on the system by the surroundings. Mathematically, this can be put as delta E internal energy equal to Q plus W. Conventionally, definition of the first law is based on the system gaining heat and the surrounding doing works. The opposite scenario can occur too, in which case the sign in the equation will have to be changed appropriately. Thus, an open system can be defined as the system that freely exchanges both energy and matter with its surroundings, while a closed system is a system that exchanges only energy with its surroundings, not matter. Coming back to the sign convention for the first law of thermodynamics. If heat flows out the system, then Q will be negative. If heat flows into the system, then Q will be positive. If work is done by the system, then W will be negative. And last, if work is done on the system, then W will be positive. Thermodynamics is a very important branch of both physics and chemistry. It deals with the study of energy, the conversion of energy between different forms, and the ability of energy to do works. As you go through this video, I am pretty sure that you will begin to appreciate the importance of thermodynamics, and you will start noticing how law of thermodynamics operate in your daily life.
Wow, that's a great explanation.
Hopefully this video will improve your understanding in thermodynamics.
Bye.
Hello guys.
Hi.
I'm Azmin.
And Brazil.
Hello guys.
Hi.
Wow, that's a great explanation.
The first law of thermodynamics, also known as the law of conservation of energy, said that energy can neither be created and nor destroyed.
Hi. Belum. Belum betul.